Okay, this is MT3 Lesson 2, Compound and Continuous Interest. Okay, the I can statement uses properties of exponents to interpret expressions for exponential functions. When we talk about the word exponential, think exponents. That's all we're going to do is exponents. Number 2, interpret complicated functions by looking at their parts individually and separately. And number 3 is properties of exponents to rewrite exponential functions. All right, okay. There we go. Vocab. An exponential function is a function of f of x equals a times b raised to the x power. Okay, this is like this, ab to the x power. Okay, where a and b are constant. A cannot be equal to 0, but b can be greater than or less than 1, but not equal to 0. This is important. B can be greater than 1, or less than 1, but not equal to 0. Because a times b, if b was 0, a times 0 is just 0, right? So we've got to change that. Okay, another formula or another expression of this another form of exponential is simple interest. A equals p to the 1. That 1 is like 100%. Plus the rate raised to the time. Notice that 1 plus r takes the place of b, okay? So r cannot equal 0. You also see compound interest. A equals p to the 1 plus r divided by n raised to the nt. Continuous interest is a equals p to the rt. So take note of these two formulas. I would write them down somewhere in your notes, okay, so that you have them. All right, okay, your teacher gave you a worksheet, and at the top of that worksheet says key features of exponential functions. Okay, so we're going to talk about where this arrow is. Okay, so key features of this graph. Okay, what this arrow is pointing to is a dotted line. This dotted line represents a asymptote. It's a boundary. The graph can get closer and closer to it, but never touches that line. The equation, one simple equation we have is 2 to the x, or 1 times 2 to the x. Notice that my a is 1, okay? My b is 2. B can be greater than 0, okay? So this is like your a, b to the x, all right? Another way you can write this is 1 times 2 is 2 to the x power, okay? All right, the domain. The domain of this graph is it's going to continue clear out here to the left. Remember, domain means the x values. Remember, we talked about domain and range prior to this lesson. So the x values are going to continue out here to negative infinity. These x values, even though they're increasing on the y, they're also increasing on the x value. They're going to go to infinity. So there's your domain. The range is going to be your y values. How low does it go? Well, it is getting to 0, but it never touches 0 because zeros are asymptote. And notice it's going up here forever and ever. It's going to infinity. Okay? All right. The next thing we're going to talk about is this one right here. Okay? It says where the function crosses what axis is this crossing right here? It's crossing the y-axis. This is also the value of a. So this represents, this is at 1, so our a would be 1. If you want to put quotations around this so you know it's not being the word it is representing an actual value in an equation. Okay, the function. You read this graph from the left to the right. So if I go from the left to the right, what's happening? It is increasing. It increases. Okay, it's increasing, okay? From the left to the right. When the function is increasing, it is considered a growth. Now, if you're like, well, what would a decay problem look like? Okay, a decay problem would cross at 1 on the y-axis, but it would come down like that. This would be a decay. Okay? All right. All right. Okay, let's finish filling in our sheet. Maybe if I can get this to change. There we go. All right. Okay. In this equation, in this exponential equation, A, the letter A is considered the initial amount. I like to think of it as the starting amount. What amount does the equation start with? Also, it is the y-intercept of the graph. So fill that in on your sheet, okay? All right, B over here represents the growth or the decay rate, okay? When B is less than 1, it is decaying. When B is bigger than 1, you have growth, okay? All right, now, sometimes you see an exponential equation that looks like this one, okay? The A again represents the same thing, initial amount, okay? B, in this case, B is represented by this whole thing here, okay? I can't copy that very good, obviously. Down and then up. It is the 1 plus or minus the R value. That is another, that took the place of this, okay? 1 plus or minus. Okay, B is 1 plus or minus the rate. R is the rate of the increase or the decrease. The percentage must change to a decimal. So in this problem, if B was 0.71, then the growth or the decay rate, change it back, move it 2 times to the right, would be 71%. So maybe on your paper, you need to write that 0.71 as a decimal is equal to 71%. Okay, how do I know that? Well, you multiply this by 100 to get that. All right? All right, okay, now, constant value added to the function. This constant value, this is what we're talking about, C. Okay, constant values can be added to the function, but they're not affected by the growth or decay. C is a constant, doesn't change, doesn't vary. Okay, oh, decay rate, excuse me, I missed this word. All right, C plus A is the constant, whatever that is, plus the growth or decay. Now, this may not make a lot of sense to you right now, but we will talk about it as we go on. Okay, that is the worksheet that your teacher gave to you, okay? Those are initially the exponential growth and decay rate formulas. All right, now here's a little quiz. Let's see if we understand any of what we just learned or can apply it or kind of figure it out from what we know. Peter invests $1,500 in the stock market. His I don't even know if I can, his stocks, there we go. His stocks increase at a rate of 9%, I think. Oh no, 12%. This is 12. Boy, I can barely read this. 12%. This is not a good copy, let me tell you that. 12% each week. If Peter also has $2,000 in his checking account, circle the expression that represents the amount of money he will have at the end of 7 weeks. All right, so let's talk about it. What was the starting amount that Peter had? I mean, what did he start with? Peter invests $1,500. His stocks increase at a rate. If Peter has $2,000 in his checking account, now checking account's going to mean at the end, okay? But we know his amount went up, right? So we kind of have to figure out what we know. If the equation above represents the total fish population in a pond, Oh, okay, so that's another problem. So hang on. So we want to think about what we started with. 1,500, right? Boy, this one's kind of crazy, guys. Okay, so I'm thinking that he's got let's just do this. Let's bag this problem. I can barely read it and kind of check it out. But let's look at this quiz too. And I'm sorry about that. Well, maybe we could just say this, but I'm not really, I don't think this is a good question. But let's just go over the vocabulary. Let's do that. Peter invests. Okay, the principal is going to be $1,500. Okay? The stock market increased at a rate. So the rate is 12%. Now, here's the killer right here. Make sure you remember this. You've got to change this to 0.12. How do you do it? Well, you got to take 12%, divide it by 100, and you're going to get 0.12. Okay, that's the rate. Okay, the time. How long does he have to make this investment? 7 weeks, right? All right, so I'm kind of looking at those problems, and so I'm thinking, okay, but what did he have at the end? Okay, he had at the end $2,000, right? All right, so I'm not really, I can't even read these, to be quite frank with you. I'm having a tough time. So let's just go with this that we just picked out the vocabulary. We're not going to worry about any of this because I can barely read those answers myself. Okay, let's go to quiz 2. Here we have this graph. What is the equation of the asymptote? Okay, now, it doesn't really, there isn't really a white marking, y equals, we're just going to put a question mark. Because right now I'm going to say 1, 2, 3, 4, 5, 6. I think the asymptote is right there, which would be at 4. I hope you at least agree with that. So we're going to say, if the asymptote is at 4, what must the value of A be? Okay? So remember, A is where it begins. What's the equation? Okay, now where it crosses is 6. Okay, so we're going to say y equals 6. Okay, in fact, the asymptote is at 4. What must the value of A be? Okay, so A has to be 6 because this is where it's crossing the y-axis at if the asymptote is at 4. Okay? All right, here's the simple interest formula. Okay, I would write this on your paper as you're taking some notes and put the A is the amount after T years, P is the principal or the initial or original amount, R is the growth or decay factor, and your growth or decay factor is going to be, if you see a plus sign here, it's a growth. If you see a negative sign here, it's going to be a decay. Okay. R is going to be the rate at which it's growing or decaying, and T is the time, usually in years, but sometimes in hours or sometimes in days. Okay. Objects that are increasing, notice that this has a positive. Object growth at decay is going to be a negative. Okay, now, if you'll get your paper that your teacher gave you, we are going to work some problems that are on your homework. Okay, first problem here. It says, a new car purchased for $17,300. The value of the car depreciates at 9.25% per year. What will the value of the car be to the nearest cent after 15 years? Now, guys, we wish that cars would appreciate. Some older cars do, but mainly all cars depreciate. So we purchased it for $17,300. That is P. The value depreciates means minus 9.25%. We're going to have to change that to a decimal per year. What will the value be to the nearest cent after 15 years? Okay, these are key words. Okay, so let's do this. P equals $17,300. Okay? Depreciates me minus. The rate is 9.25%. Let's change that to a decimal, 0.0925. Remember, divide 9.25 by 100. Okay, what will the value be in 15 years? So time is 15 years. And we're looking for A, the amount that that car is. Okay, they give you this little formula right here. We're going to plug things into that formula. So it says A equals P times 1 minus R, because it's depreciate, raised to the T. Okay? All right, so we have amount. We're trying to find it. $17,300 times 1 minus the rate, which is 0.925. 0.925 raised to the 15. Now, sometimes I would just punch it in your calculator the way it is. If you want to simplify this, you get A equals 17,300 times 0.9075 raised to the 15. Okay? Either way, when you punch that into your calculator, you're going to get 15,699.75. Okay? All right, so that is how much money that the car is worth in 15 years. Okay? All right, let's do this one. Given the following exponential function, identify whether the change represents growth or decay and determine the percentage rate of increase or decrease. Okay, now notice this number in here is a 1.82. This probably was this 45. And how did I get 1.82? I did 1 plus 0.82 raised to the x. All right, now, if it is a plus sign, it is a growth. So this is the one you'll change. The 1 right here means 100%. That's what that 1 means. This means 82%. So how much did it grow by? We added what? 82% increase. Okay? So hopefully that will help you. Okay? All right, next problem. In a lab experiment, a population of 400 bacteria is able to triple every hour. That's why when you get bacteria, guys, it's deadly if you don't get it under control because it just keeps growing and growing at such a fast rate. Which equation matches the number of bacteria in the population after 3 hours? Okay, now we're going to use this equation, which is y equals a times b to the t. Okay? Okay, now we've got 400. This is going to be your a value. This is what we started with. This is a. That is our beginning amount. Okay, our time is going to be 3 hours. Now, what do I do with this triple? It is tripling every hour. It's multiplying. As it triples, it's multiplying. So that becomes your b value. Okay? So we're going to plug it in this formula. Y equals a times b raised to the t. So we have y equals 400 times 3 raised to the 3. So it'd be this formula right there. Or that answer, excuse me. Okay, linear versus exponential. Now you have to remember linear has slope. And it increases in, like if you have 3 over 1, it's increasing up 3 over 1, then up 3 over 1, up 3 over 1. Exponential means that it's continuously multiplying. So let's look at this. An elevator descends at a rate of 9 feet per second. That would be 9 over 1, okay? 9 feet. This is a slope. Whoop, can't spell slope today. Okay? A car depreciates at a rate of 6.6% per year. That means over and over and over and over and over. Now, you have to think about it. The elevator, it probably ends up hitting 0 at some point, gets down to the ground. A car depreciates at a rate at 0.6% a year. A car's value is really never worth a 0, okay? So that one's just multiplying and multiplying and multiplying. So that's exponential. A coin collection appreciates at a rate of 8% per year. So appreciate just means it multiplies itself over and over and over again. That's why rare coins are worth so much. They go up every single year. A population of 250 bacteria quadruples every month. We just did a problem like that. We know it's exponential because bacteria can just keep growing and growing and growing. It says, which of the contexts below could not be modeled? So we want to choose an elevator because it has a slope of 9 over 1 in this particular problem. Okay, linear versus exponential. Okay, let's take a look at this function, and we're going to try to determine, is it a linear function or is it an exponential function? Okay, so I'm looking at this problem and I'm thinking, okay, I want to look at my x values right here. Okay, what's happening between 1 and 2? Well, you added 1. What's happening between 2 and 3? You added 1. What's happening between 3 and 4? You added 1. Okay, good job. Okay, so that's pretty consistent. Add 1, add 1, add 1. Okay, let's look at the y values right here. These are the y's. F of x is y. Okay, so can you look at this and see what's happening? How do I get from 1 to negative 10? Well, you added negative 11. How do you get from negative 10 to negative 21? You add negative 11. How do you get from negative 21 to negative 3? You add negative 11. That's an add sign, PS. Okay, so if your x's are increasing at a consistent rate, your y's are decreasing at a consistent rate, it is linear. Okay, the function is linear. Because the x increases and the y value changes additively. We're adding negative 11 every time. Okay, we're adding negative 11 every time. All right, then it says the something of this function is exactly, okay, so now think about y over x. What is that called when I have y over x? Well, this is the slope, okay? So let's put this in. It is the difference slope, and I believe this will be in your drop-down menu, okay, is exactly negative 11, okay? All right, okay, please finish up your compound interest worksheet, which is really your Delta Math assignment, okay, or your figure that out, and then enter your answers in on your Delta Math assignment. Okay, here's an extension for students if you want to earn some extra credit. The next few slides add extensions for basic exponential functions. Talk about compound interest formula, continuous interest formula, solve for interest and rate, and solve for initial value. Okay, compound interest formula is this. Okay, it's similar to the other one, but notice what we had A equals 1 times 1 plus R, but look at this n. N is the number of times it's going to compound, raised to the number of times the time. So that's the new part of this formula, okay? All right, compound interest problem. If you deposit $4,000 into account, so you deposit, this is your principal, so let's put P equals 4,000. Paying 6%, that is your rate, okay? And interest compounded quarterly. Quarterly means 4 times. How much money will be in your account after 5 years? Okay, we are going to use this formula. A equals P times 1 plus R divided by N raised to the NT. So we're going to say A equals 4,000 times 1 plus the rate 0.06 over 4 raised to the 4 times 5. Okay, now you can just pop this straight into a calculator, but I want to caution you on a couple things. This has to be in its own set of parentheses. When you hit your exponent, you probably need to hit 4 times 5 and put it in parentheses. Okay, when you do that, guys, you're going to get out a really nice number. A equals $5,387.42. Okay, that's how you plug that in. Okay, compound interest problem. We're going to use that same formula again. You deposit $6,500. That is your P. Into an account, paying 8%. Change that to a decimal, 0.08. Compounded monthly. Monthly means how many months in a year? 12. How much will there be in 7 years? Okay, I'm going to plug it into this formula right here. Okay, so we're going to say A equals 6,500 times 1 plus 0.08 over 12. Okay, now remember I told you put this in its own set of parentheses, raised to the 12 times 7, and put that in parentheses when you hit your exponent key. Okay, when you do that, you're going to get $11,358.24. Now, guys, that's just by leaving your money in the bank. Just let it sit there at 8%, and in 7 years, you've almost doubled your money, or getting pretty close to it, just by letting that sit in the bank. That's what we talk about. Let your money work for you. You just have got to let it sit there. Now, are you going to have to pay taxes on that money that you earned? Yes, but hey, you're still ahead of what you had before. You've got more. Okay? All right, now you use this formula now let's back up. This is when it says compounded. You use this formula. Okay, when you see the word continuous, you're going to use this formula. Now, this E, P we know E. Everybody look at your calculator and see if you can find a key that says E to the X. It might be on the second function key. It's usually with ln. This might be in the second function. You may have to go second ln to get that E to the X. Okay? You need that key to help you work these problems. Okay, Rachel opened a savings account and deposited $800 as the principal. So the principal, she began with $800. Okay? The account earned 13%. The rate, 13%, is going to be 0.13. Compounded continuously. So if I say compounded continuously, I'm going to use this formula. What is the balance after 1 year? Time is 1. Okay, let's plug in our stuff. So A equals 800. E is what we call a natural logarithm. Okay? And then we're going to raise it to the 0.13 times 1. Okay? So hit your E button. It's waiting for the exponent. Do a left parenthesis, 0.31 times 1, right parenthesis. When you punch that all in with that 800, you'll get $911.06. So after 1 year, you've earned about $111. Not bad. Just by letting your money sit there. Okay, continuous interest problem. Let's do this. Suppose $5,000 is put into your account, pays a rate at 4%. That means, guys, it's going to be 0.04. Continuously, how much will the account have in 3 years? Okay, here's the key thing. Compounded continuously, so you can use this formula. A equals P to the E RT. Okay, A equals 500 E to the 0.04 times 3. Okay, use those parentheses, and you should get, guys, $5,637.48. Okay? Okay, it looks all, let's see, solving for the interest rate. Okay? All right. I'm going to do this problem with you. It says it looks all new and scary, but we have done this before. You can do this. Emily invested Okay, so invested means that's the principal, $1,250. The time after 2 years was 2. But now she knows the amount. This is what she gets when after her investment. That's what she started with this. She's now got this, okay? What was the interest rate? We don't know, but we're going to figure it out. So we are going to use A equals interest rate assessed once a year. Time is 1. Okay, all right, time is 1. Okay, A equals P times 1 plus, now it's going to be a plus because she went from this amount to this amount. She went up. R times T, right? Okay, so we're going to put right here 1281.45 equals 1250. That's a principal times 1 plus, we don't know the rate, but we do know the time is a 1. Okay, is that, oh, after 2, excuse me. Boy, I'm going to tell you what, I've got this wrong on my answer sheet, so we're going to have to figure this out. I'm going to have to redo this. Let's see, if the interest rate was assessed once a year, okay, does that give me the number of times it was assessed? Yeah, so my N is going to be 1. So we're going to have a 1 right here, and we're going to have a 1 times 2 here. Okay, now 1281.45 equals 1250. Now, R divided by 1 is what? R. 1 times 2 is what? 2. All right, guys, this is where you're going to need your handy-dandy calculator to give you some help. All right? Okay, let's try this. Okay, first thing you're going to do is this is times. What's the inverse of times? Divide. We're going to divide by 1250 here. We're going to divide this by 1250 here. So we're going to get 1 plus R squared equals. Okay, now, I'm going to be doing this right along with you guys because guess what? I had a wrong answer. 1281.45 divided by 1250 equals, okay, I got 1.02516. Hopefully that's what you guys got to. Okay, now, look at this exponent of 2. How do you undo something being squared? Use square root. So that's going to give me 1 plus R over here. Okay, what is the square root? That didn't work on my calculator. Hope your calculator's working. 1.02516. What's the square root of that, guys? Okay, I got 1.0125. That's as far as I'm going to go out. Minus 1, minus 1. Okay, I'm going to go over here. Okay, I'm going to get 0.0125 equals R. Now that's the decimal, but what is the actual percentage rate? Well, you got to move it 2 times the right or times it by 100, 1.25%. This is the number that you need. All right. Okay, guys, I'm going to let you try your extra credit problem number 6 by yourselves. Okay. Turn your extra problems into your teacher extra credit ones so they can make an adjustment, give you some bonus points for your hard work. Okay, thanks guys. Hope that helps you get through your assignment.